go. All right, so got that one all set up, got that stream all set up. There we go. Making sure we're all signed in, ready to go. Welcome, welcome. So today is Monday. No, don't need YouTube on this. I need Twitch over on this one. So make sure my volume's down. There we go. Volume is down. Go over here, Stream Manager. All right. So today is August 17th, 2026, and currently going through, actually I should say it's the time. The time is 1:08 in the afternoon, so a little bit of a later start to today. But anyway, so what's the stream about? The stream is about preparation for academic studies, in particular a math major, or starting that here shortly. And so it's a process of going through and copying or learning how to use certain tools that are going to be useful for me in my studies as far as note-taking goes, and study habits in general, and also practicing and learning how to present things on the fly, and just develop more fluidity in my style and in my approach. So So the book that I'm going through, the book that I am working through, copying, is Augustus De Morgan's The Elements of Arithmetic, as the title puts it. And we're currently working, we have just finished the section on arithmetic and subtraction, or on addition and subtraction, and we're currently working through multiplication and powers is what we're getting to now. So anyway, that's kind of that's where we're at. I do all of my notes in Gregg Anniversary Shorthand. That is a style of writing where it is a phonetic transcription of the language, and then a further compression of the forms based on brief forms and brief words. And that's pretty much all there is to say. It's just, as you'll see, it's kind of slow, kind of boring, kind of uninteresting in a way, but it's just it's part of the growth process of just learning to present and learning to navigate. I use I've got my PDF reader set up here. I have my word lookup located down in the lower left-hand corner, and then of course I have my copy board right here. There we go, just sent it across. And so it's just a matter of, just keeping track and trying to be as engaging as I can. So as you see, the timer is set for 2 hours. That is 2 hours and 45 minutes. I generally like to stream for about 3 hours at a time. Yeah, so essentially it is the most boring. It's the most boring mental gym that you'll ever see. And so with that, let's go ahead and get started. So I had just finished up, in fact, in order to read through, I'm going to go ahead and read through so that you can see where we're at. And if you see there in the top left-hand corner, we have the English, and then over here, as I go across, you'll see I can highlight. I highlight each word as I say it. I highlight each word as I say it. Okay? Now let's begin. So we have the second and third powers are usually called the square and cube, which are incorrect names derived from certain connections of the second and third power with the square and cube in geometry. So that's where we left off on Friday. And now I begin with the continuation. Here we go. As exercises in multiplication. So we go as exercises in multiplication. Now from time to time I will have to look up stuff, so there we go. And that is correct. The K is just a little bit too extreme, so let's go ahead and minimize that. Make it a little smaller. There we go. As exercises in multiplication, comma, the following powers are to be found. And I'm not going to bother with those, but you see, if you wished, then you have the number proposed, the square, and the cube, and so on and so forth. And those are just the listings of the values, right? So you have for instance, the number proposed is 3,163. The square would be 10,004,569. The cube would be, hold on, I'm counting backwards to make sure I get my correct value. So there's hundreds, hundred thousands. Hold on. You see here, hundreds, 100,000s. That'd be 31,644,450. No, 31,644,451,747. So you see, the numbers get big real fast, okay? So we have all of these different powers, okay? And that's just the demonstration. Now we'll go on with our reading. So we have 67. Yay, 67. I know. An old meme. Still funny, though. So we have a new paragraph here. And this is 67, period. It is required to multiply a plus b by c plus d. It is required to multiply a plus b by c plus d, comma, that is, comma, to take a plus b as many times as there are units in C plus D. Let's go ahead and add another page. Elements of not animation. Elements of Arithmetic, section. This is section 3. currently on page number 10. All right, zoom back up. That way we're centralized. There's nets, units in C plus D. By, and then of course this is speaking of the paragraph number, by paragraph number 53, A plus B must be taken C times. And D times. Comma. Or the product required is A plus B C plus A plus B D. Period. But, according to 52, A plus B C is AC plus BC. Let's make this a little smaller so it can fit on one line. Comma. And A plus BD in parentheses is AD plus BD. Is AD plus BD. Whence the product required. Whence. Let me check whence. There we go. Required is on a separate line below. AC plus BC plus AD plus BD. Or, comma, on a new line, this is showing the expansion of the forms. AB, A plus B, times C plus D is equal to AC plus BC plus AD plus BD. Ran out of room there, so I might need to shift my first portion over. There we go. AC plus BC plus AD plus BD. By similar reasoning, similar and then I might need to do this. Oh, might be able to fit it on the same line. A minus B and C plus D is, and then we expand it out, A minus B times C plus A minus B times D. Or, comma, if we expand it out, we get this following formula. A minus B times C minus D, or times A minus B, so the difference between A and B, and I should say the product of the difference between A and B, and the sum of C and D. And the sum of C and D is equal to the product of A and C, the difference of B and C, and the sum. So it's actually it's equal to the product, or the sum of the differences. The sum of the differences. So it's the sum of the differences of the products of AC and BC, and the difference of AD and BD. So there we go. So we would say that, or a way of saying this in English would be to look at the product of the difference of A and D, and the sum of of A and B, and the sum of C and D is equal to the sum of the differences of the products. It's equal to the sum of the differences of the products AC, BC, and AD, BD. So there we go. All right, so going on. To multiply, so here's next line down, new paragraph. To multiply the difference of A and B by the difference of C and D, you must first take the difference of A and B, C times. You take the difference of A and B, C times, comma, which gives the difference of the products of AC and BC. Might have to do this on another line. Zoom down. All right, the difference of the products of AC and BC. This is not correct, comma. I like the way that Augustus De Morgan does this. He presents something as being true, and then he shows logically why it doesn't work. This is not correct. Semicolon. For in taking it C times, instead of the difference between C and D times, we have taken it D times. Too many. We have taken it D times too many. Semicolon. Or have made a result which is the product of the difference of A and B and D too great. So the difference of A and B and the product, I should say the product of the difference. The product of the difference of A and B and D too great. The real result is therefore and then we lay it out, AC minus BC minus, and then we have A minus B times D. But A minus D times D is AD minus B. AD minus, that should be AD minus BD. Losing a little bit in the printing. But the difference of AD of AB multiplied by D is the difference of AD minus, or I should say it's the difference of AD and BD. And therefore, we lay it all out here. The product of the differences of A and B, C and D is equal to the differences of the differences. As you see this, the differences of AC and BC minus AD minus BD, which then is simplified as AC minus BC minus AD plus BD, like so, according to 41. From these three examples may be collected the following rule for the multiplication of algebraic quantities. So let's see, let's see, I can go ahead and copy out the end of Article 67, and then I'll go back and read through them all. From these three examples, may be collected the following rule. Collected the following rule. For the multiplication of algebraic quantities. And algebraic, check that. Now that would be algebraical, right? Let me check. That's right. If you connect it, it is algebraic. If it's disconnected, it's algebraical. The following rule for the multiplication of algebraic quantities. Quantity. Colon. Multiply each term of the multiplicand by each term of the multiplier. Each term of the multiplicand by the multiplier. Let me check multiplier. Is it a disjointed? No, it is. It's joined. It is joined. semicolon, when the two terms have both plus or both negative. When the two terms have both, is that both or bother? That's bother, and then what is both? Oh, okay, both and bother are the same thing. Good, good. Good, good. Have both plus, have both addition, or both subtraction. And I'm going to put a couple lines under that to show that we're talking about the multiplication, or the signs that are non-Greggian. When the two terms have both addition or both subtraction before them. Comma, put pluses before their product. Semicolon. When one has a plus and the other has a minus, oh, and that should be the plus sign, of course. When one has plus and the other minus, comma, put minus before their product. In using the first terms, comma, which have no sign. And which have would actually make a good phrase, which have no sign. Apply the rule as if they had the sign of positive. As if they had this sign. Of addition. Period. That is the end of paragraph, or of article 67. And so now let's go ahead and go back over and reread article 67. If I remember to drop a paragraph marker, it is required to multiply a by d. So we're looking for it is required. And there it is. Drop a highlighter. We begin. Here we go. It is required to multiply a plus b by c and d. That is, to take a and b as many times as there are units in C and D, C and D, by, according to Article 53, A plus D, but according to 53, A plus B, or the sum of A and D, or no, A and B, must be taken C times and D times, or the product required A plus B C times plus A plus B D times by Article 52. The product, or the sum of A and B taken C times, is the product of A and C plus, or the sum of the products of A and C and BC. And A plus B taken D times is the sum of the products of AD and BD. And then that's the whence let's make the just a little bit more pronounced. Whence the product required is the sum, or you could see here, it's the sum of the sums of the products. The sum of the sums of the products. And those products are AC, BC, AD, BD. So the way that you want to think about it is the sums of the sums. The sums of the sums. All right? And then if this is written out, we get the product of A and B and C and D, or A times B plus A plus B times C plus D is equal to AC plus BC plus AD plus BD. Okay? So remember, the product of sums is equal to the sum of the sums of the products. Okay? Again, if you have four terms, the product, right, of the sums is equal to the sum of the sums of the products, or the sum of the products. Product of sums is equal to sum of the products. All right? And that's for four terms, for four unique terms. Next paragraph. By similar reasoning, the product of a difference and a sum, so the product of a difference and a sum, is the difference taken the first term of the sum times, plus the difference taken the sum of the second term times, or A minus B times C plus D. The product of a difference and a sum is equal to the sum of the differences of the products. Okay? So once again, the product of the difference and a sum is equal to the sum of the differences of the products. Okay? To multiply the difference A and B by the difference C and D, first take the difference AB C times, which gives, and that G should be just a little bit longer. There we go. Which gives the difference of the products AC minus BC. This is not correct. For in taking the C and taking it C times instead of the difference of C and D times, we have taken it D times too many, or have made a result which is the product of D and the difference of A and B too great. Okay, so this whole term, whatever the result of this value would be, we have that times too many. What is that? There we go. The real result is therefore you take your difference of the product of AC and BD and minus, and then you are removing the quantity that was left, which is the difference A and B time taken D times. But, or by, where's that but? I think that's but. I must have forgotten I forgot the paragraph number. But according to 52, no, hold on. No, I'm too far ahead. That's what it is. Yep, I don't have to worry about that. There we go. So it was just making a logical argument. But the product of differences, or hold on, let's see. But the difference AB taken D times is equal to the difference of the products. The difference of the products AB and BD. And therefore, the product of differences is equal to the difference of a difference and a product and a sum. Okay? The product of differences is equal to the difference of a difference and is equal to a difference of the difference of products and the sum of products. AC minus BC minus AB minus AD plus BD. Okay? So that's the idea. So those are the three forms. And then we read the next portion here. From these three examples, let's go ahead and underline the three. From these three examples may be collected. See if that's collected. Oh. Hopefully I didn't change anything. Doesn't look like it. Yep, that's collect. Good. May be collected. Collected is here. The following rule for the maybe collected the following rule. 4, yep. The following rule for the multiplication of algebraic quantities. Multiply each term of the multiplicand by the multiplier. When the two terms have both positives or negatives, in other words, if they are both sums or they are both differences, before them put a plus. Or you're going to be finding the sum before the product. Okay, so if they are both, if the two terms have both product or have both sums or differences before them, put a sum before, or a positive sign before the products. When one has a sum and the other a difference, put the difference sign before them, before their product, Okay? In using the first terms which have no sign, apply the rule as if they had the sign of positive, or as if they were a sum. Okay? So that's it for 68. So once again, the three rules are, where's the first one here? It's down. So let's take a look. If you take, where is it? Yes. So if you have right here. So if you're looking at the product of sums, this is going to equal the sum of all the products. Okay? Once again, the product of sums. If you have four terms, the product of sums is equal to the sum of all the products. Every term multiplied by every other term. Every term multiplied by every other term. AC and BC, AD and BD. Well, and it's not every other term, that's actually incorrect. You simply find the products of the terms AC and BC, okay? So you take the last two terms and you simply multiply them out to the terms of the first sum, okay? All right? And then the second one is if you have a case where you are looking at the product of a difference and a sum. The product of a difference and a sum. This is going to be equal to the sum of the differences of the products. The sum of the differences of the products. Once again, you take the last two terms and you multiply them by the first two terms, take their difference, and then you find the sum of the exact same process by taking the first two terms and multiplying them by the last two terms and taking their difference. So the product of a difference and a sum is equal to the sum of the difference of their products. Okay? And then the final one, of course, was in the case when you have the negative, when you have the product of differences. The product of differences. The product of differences is equal to the difference of their products and the sum of the products. Okay? The product of differences. The product of differences is equal to the difference of their products and the sum of the products. Okay? AC minus BC minus AD plus BD. And that's it. So now we'll go forward to 68. For example, A plus B times A plus B, or the product of a term. The product of a sum times itself. That's essentially what's going on, right? The product of a sum, AB, times the same sum, AB, gives AA plus AB. Remember, that the product of sums is the same as the sum of the products. So AA and AB plus, and then the second sum would be AA plus AB. Okay? All right. But, so here's our next one. But AB plus AB is 2AB. Okay? That's the constant pulled out in front, right? 2, it's a quantity of 2AB. Hence, oh, and I wrote the 2 backwards. Rats. Let's fix that. Is that right? 1. Yeah, there we go. Yes. Huh. Okay. Hence the square. And so this is called the square, right? Hence, and let's go ahead and fix that. Hence, the square, and square was S, curves up on the top, I believe, and then it does a line below. Let's check that again. Yep, that's square. Let's go to segment mode. Ah, square is the only instance of square in the dictionary. So the square of AB is AA plus 2AB plus BB. Okay. Now, what's interesting is that he doesn't really get into powers. We could easily rewrite that as a power if we wanted. I'm not going to worry about it right now, but it is good to know that that's the case, okay? So, hence the square of AB is AA plus 2AB plus BB, which in more modern terms, I'm going to go ahead and put this in parentheses, is A squared plus, let's see here, would be A squared plus 2AB plus B squared. Okay. Means the same thing. Again, so now we're going to go back. Again, the product of differences, and this is the product of the difference of a term, right? The difference, it's the square. Actually, in essence, it's the square of a difference. It's the square of a difference. Again, the square of a difference, which we could write this out like that, correct? That's the square of a difference. I'm going to go ahead and add another line below. This is number 11. Now, did I just make a mistake? Is this part 4? No, this is all the same. Okay. For some reason I was thinking that we had started another section. No, oh, no, that's division. My mistake. We're actually getting, we're getting to the end. Beautiful, okay. And then we get to start another section, which is division. Okay. So we were looking at the square of the difference. This is the new page, which I don't even know if we're going to need. I'm just going to put it there, and we can delete it at the end if need be. Again, the square of a difference, which is, if we expand it out, I'm just going to say which is AB, the difference of AB times the difference of AB. In other words, the square of the differences is equal or gives and same thing. He has AA. I'm just going to go to A squared. Okay? Yeah, it's A squared minus AB minus AB. Okay? Plus, it's plus B squared. Okay? Remember that the product of differences is equal to the difference of the, it's the difference of the difference and the product. No, yeah, boy. All right. The product of differences is equal to the difference of the difference of products and the sum of products. Okay? The difference of their products and the sum of their products. Okay. Now I got it. So we have that where it's A minus B times A minus B, or the product of difference, or the square of a difference, gives A squared minus AB minus AB plus B squared. But two subtractions of AB, okay, but two subtractions. And of AB are equivalent to subtracting 2AB. Are, and then equivalent, equivalent, something like that. Let's go check equivalent. There we go. So it is EKE with a line. Okay. But two subtractions of AB are equivalent to subtracting 2AB. Semicolon. Hence, the square of the difference AB is the square of A minus twice the product of the two terms. Just put it on the line down below, or line over here. So it is equal to the square of the first term minus twice the product of the two terms plus the square of the second term. Okay? So the square of a difference is equal to the square of the first term minus twice the product of the two terms plus the square of the second term. All right? And we go forward. Again, A plus. Again, if we have the product of the difference of two terms, or the product of the sum of two terms and the difference of the exact same terms, okay, so what happens in that instance? If we have A plus b, the sum of two terms. Might have to do this on the same line. If we have the sum of two terms, and then we find the product, we're looking for the product then of the difference of those same terms. So it's the product of the sum of two terms and the difference of two terms. It will give us AA. It gives A squared, okay, plus AB minus AB minus B squared, or the square of the second term, okay? Hence, no, this is period, but the addition and subtraction of the product of terms makes no change. But the addition and the subtraction of the two terms of AB makes no change. Semicolon. Hence the product of of the sum of two exact same terms, so the product of the sum of two terms and the difference of the same terms is going to be the difference of their squares. The difference of their squares. Okay? Kind of an interesting concept, isn't it? So if you have the product of, so you have two terms that are the exact same, right? Two terms the exact same. The product of their sum and their difference is equal to the difference of their squares. That's what it means. Okay? And let's go ahead and finish up the rest of this. Yeah, let's go ahead and write this next paragraph. And then once we write the paragraph, then I will go ahead and read through the whole thing, okay? Again, the square of four terms. Again, the square of four terms, of the sum of four terms, A plus B plus C plus D, or, so the square, I'm just going to do the power sign to be honest. You could see what he's doing there in the book, so I'm not going to worry about it. So it's A plus B plus C plus D taken twice, right? That's the square. That's the idea of the square. Will be found, it will be found to be the product, or the square of the first term, plus the sum of the first two terms, plus the sum, no, plus twice the product of the first two terms, twice the product of the first two terms, and twice the product of the first and the second term, or first and third term, and twice the product of the first and fourth term, okay? And the sum of the, there would be the product, it would be the square of the second term, the square of the second term plus twice the first and third term, twice the first and third, second and third term, twice the product, sorry, my glasses bumped into the microphone, plus the twice the product of the second and third term, the second and third term, plus twice the product of the second and fourth term, twice the product of the second and fourth term, plus the square of the third term, and twice the product of the third and fourth terms, plus the product, or plus the square of the last term. Okay? That is quite the mouthful, okay? So if you find the square, if you're looking for the square of 4 terms, or actually the rule for squaring such a quantity is square the first term and multiply all that come after by twice that term. Do the same with the second and so on to the end, okay? So in this instance, if we have 4 terms, right? We have 4 terms. Then what you do is you square the term, and then you multiply, and then you add, multiply all that come after by twice that term. So if you have a, for instance, a, you square it, and then you multiply by twice that term. So that's twice ab, twice ac, twice ad. Next one, it would be b squared, and then twice bc, twice bd. Then c squared plus twice cd, and then finally you square d, but nothing comes afterwards, so that's why it simply is just tacked onto the end. Or another way to look at it is make sure that you have twice, so it's a squared, and then twice the first, the product of first and second, first and third, first and fourth, second term squared, twice first, second and third, second and fourth, and then the third term squared, twice third and fourth, and then finally fourth term squared. All right, or the rule, so now we can actually write that out. It's a good rule. Or the rule for squaring such a quantity is for squaring such, is such backwards? I think such is backwards. Yes, it is. For squaring such a quantity is such a quantity is, and then colon, square the first term, comma, and multiply all that come after, and multiply all that come after by twice that term, by twice that term. I do need to check twice. Yep, that's twice. Go ahead and fix that up a little bit. By twice that term, semicolon. Do the same with the second. Comma, and so on to the end. And so on to the end. All right, let me read through that. So let's go back to the beginning of 68. Hopefully I remembered to drop a paragraph marker. Not, we'll look for 60. There's 68, so let's drop a paragraph marker now. There we go. And we begin. For example, the product of the sum, the product or the square of a sum, the square of a sum gives the square of the first two terms plus the product of the two terms plus the square or plus the, oh, I think I did that incorrectly, didn't I? Yes. Yeah, that should be AB, not AA. Wait, undo. Oh, did I just swap the order? I did. A squared plus AB plus AB. There we go. And then plus B, B, and B. There we go. All right. So A squared plus AB plus AB plus BB. But the sum of the products AB gives twice AB. Hence, the square of the sum AB is the square of the first two terms plus twice the product of the two terms plus the square of the two terms, or A squared plus 2AB plus B squared plus B squared. Okay? And that's right, this 2 needs to be written the other way. Once again, I do things mirrored, and the numbers kind of do funny things every once in a while. Again, let's go ahead and grab that. Again, the square of the difference of two terms, which is so that would be the difference of A and B times the difference of A and B, gives A squared minus AB minus AB plus B squared. But two subtractions of AB are equivalent to subtracting 2AB, whence the square of the difference of A and B is, over here, is the square of the first term minus twice the product of the two terms plus the square of the second term. Again, and then here's the final one, right? Again, the square. Again, the product of the product of the sum of two terms and the difference of the exact same terms. The product of the sum of two terms and the difference of the exact same terms gives the square of the first term plus the product of the two terms minus the product of the two terms minus the square of the second term. Okay? But the addition and the subtraction of the product of A and B, or the product of the two terms, makes no change. hence the product of the sum of two terms and the difference of the exact same terms is the difference of the square of the first term and the square of the second term. Okay? The product of two terms and the difference of the exact same terms is equal to the difference of the square of the first term and the square of the second term. Again, the square of four terms of the sum of four terms, a plus b plus c plus d, or another way to write it would be a plus b plus c plus d squared, will be found to be a squared plus 2ab plus 2ac plus 2a plus 2ad plus b squared plus 2bc plus 2bd plus c squared plus 2cb or 2cd plus d squared. Okay? Or, and let's move this down here, the rule for squaring such a quantity is square the first term and multiply all that come after by twice that term. Do the same with the second and so on to the end. I will be right back. Okay, back at it. Let's go ahead and continue. So, got everything pulled up here. That was the end of section 4. That was the end of section 4, which is really neat. So, or no, of section 3. So that means we can go ahead and export section 4 or export section 3 and start section 4, which is going to be division. Now that's kind of interesting because notice how in his multiplication he has already started dealing with algebraic terms and algebraic concepts. So really fascinating that's going on. And now we go ahead and scroll on down to section 4, which is, as I said, is going to be division. And he's going to introduce the concept first and foremost as he's going to introduce it in its algebraic sense or in its arithmetic sense. And then from there, he goes immediately into the algebra. Okay? Really just his approach is so interesting. Which means he might get into ratios as well. Okay, so we've got that pulled up here, section 4, and we're on page 34, right? And this is, notice how it says principles of arithmetic, and it's articles 69 through 71. So it's laid out really, really well. But before I do that, I need to go over to Zernal. I need to save the page, and I need to export it as a PDF. Export as a PDF, and we're going to save it in fundamentals, and this one is addition subtraction 0.002. This is going to be section 3, so we have 003. And this one was multiplication. Multiplication.pdf, good, export, and now it's being exported. Okay, so once it's been exported, then I can go ahead and save this as a new document, and this one's going to be number 4, and it's going to be section number 4. So 004 and section 4. Okay, save it as a Zernal note, and now I can zoom out. And what I'm going to do is I'm going to delete all except the last page, okay? So we'll go down, and we're going to go D. Oh, wait, no, it's Alt-Shift-D, right? What is it? Journal, delete, page, Control-Shift-Delete, okay? There we go. So we only need 2 pages left. So going through, 3, 2. And then I select everything and I delete it. And I select everything and I delete it. Oh, select everything, delete. All right. And now we're going to go ahead and label these 2 pages as being Elements of Arithmetic, section 4. Okay. Elements of Arithmetic. Elements of Arithmetic, section 4. This is page number 1. Okay, save that. And now we do the same over on the next page. So scroll down, zoom in, and same thing. We go ahead and label this as Elements of Arithmetic. Elements of Arithmetic, section 4. Page number 2. So now we have the 2 pages all lined up ready to go, and now we can go ahead and get started. Go save Scroll back up. Zoom in a little. Okay, and now we start section number 4. So, section 4. Division. And division is, I think it's just, isn't it just that character right there? Go to division. That is division. Good, good. Okay, so we'll go ahead and lay this out like so, and that's division. So now this is Article 69 is where this starts. So we go ahead and drop a paragraph marker. This is where we need to start, and we're doing 69, okay? Article 69. Period. And we start. So we go, suppose, let me check and see that if that is suppose. Yep. Suppose I ask whether I ask, and whether, I think it's, isn't it just with? Yes. Suppose I ask whether 156 can be divided into a number of parts. Can be divided into a number of parts. And let me check divided. Just a longer stroke for divide. Can be divided into a number of parts, each of which is 13. Or how many 13s 156 contains. Or how many 13s 156 contains. Semicolon. I propose a question. Let me go ahead and check propose. There it is. I propose a question. One thing I do want to check is I need to go to Journal, and I need to set my pen so that it can go just a little bit faster, because currently it's starting to become a little slow for my liking, and I need to be able to write just a tad faster. So if I go to preferences, you guys can't see this, but I'm just opening up preferences here, and I'm going to my input system, and I need to change my drag just a little bit. So let's drop the drag. Oh, okay, if the value is too small. So let's increase the drag to maybe 0.4. And then what about the alpha Gaussian parameter? The higher, the more stabilization and the more lag between your cursor and the painting tip. So let's go ahead and drop the Gaussian parameter to maybe 0.10. And what's the mass? The more inertia and the more stabilization. So let's go ahead and drop the mass down to 1.7. And let's hit OK. And let's see what the pen is like now. So I'm in here. Oh yeah, that feels much more responsive. So let's see if that helps us at all. I propose a question, the solution of which is called division. And then solution. So maybe it was just the inertia was a little too high. Let me go ahead and switch it to, because I want it just a little bit, to have a little bit more inertia. So I'm going over to preferences, I go to edit, and then I go to preferences, I go to input system, and I want the mass to be just a little bit higher. So let's try 1.9. Let's see if that helps us at all. So I'm going in here. Yeah, that still feels pretty good. So let's go to solution. Okay, there's solution. I propose a solution. Oh, the solution. Now it's gone jittery. So let's go ahead and fix that. Go to preferences, going to input system, and I'm going to Gaussian weight. So let's go ahead and do a little bit of a higher number. So maybe 1.2 on the Gaussian weights, and the inertia, the drag, there will be no stabilization. So let's go ahead and drop that down to 0.45, 0.4. Okay, let's see if that helps us out. So we'll go to solution again, and let's try writing it. Yeah, there we go. Yeah, that feels good. It's a little bit of a jagged edge, but it's okay overall. The solution of which is called division. The solution of which is called interesting. Now I can see so I don't quite like that shape. Let's go ahead and increase. We'll go to edit, go to preferences, and go back to input system, and let's try decreasing the drag just a little bit. Let's try increasing the stabilization to 3. Okay, so let's try this, of which is what? Trying to fix it again. So we'll go back over to Zernal, called dialing in your settings, you know? Let's try increasing the mass to maybe 2. Okay, try it now. Because there is such a thing as just getting better at the input, but I also don't want that jagged is called. Maybe I'll just get used to it, but think I changed the settings too quickly. Maybe I can't remember what the weights were. Let me go back and try it. Go back into edits, preferences, input system, input stabilization. Let's try bumping our mass back up. The higher. Let's try bumping our alpha back up to maybe 0.6. The higher the mass. Let's try 0.2. Okay, let's try that value. Of which is called division. Okay, so this feels like I would be able to get used to it, because gradually you do want to get faster, which then you don't have to worry about the shape. It definitely, yeah, it should be. Man. Let's increase, going back to input system, and I'm going to increase the gamma, the Gaussian parameter. Let's take it to 1. Oh, is that the pen? Hold up. Or have I just learned a bad form? That's no fun. Yeah? Huh. Let's bump the Gaussian. We'll just bump the Gaussian back up. Let's let's take the Gaussian parameter until it becomes obscenely slow. So we'll go down and let's take the Gaussian up to 3. Let's see what happens, then we'll back it down. Okay, so here's the Gaussian. All right, so now that's smoothed it out, so that's the Gaussian at 3. Okay. And that's a little too high. Okay, so now I can back it down if that's division. So that's a little bit too high, like I said. And so now let's back it down to, go back into edit. And once again, this is using Zernal. So I just went into edit and I went to input system and okay. Hover, tip, button 1. So let's try dropping the Gaussian back down to maybe just 2.5, because it was close. Yeah, that should do it. So let's try it now. Let's work with that at 2.5. Just drop the Gaussian parameter just a hair. So I'm going to go back in here, which is called division. Okay, and this is in caps and underscored. In this case, 156 is called the dividend. 156 is called and then dividend. Dividend, maybe? Let's go check. Oh, all right. Pretty close. Pretty close. It's called the dividend. Underscore. Comma. 13, the divisor. And let's check divisor. Okay, so we just scroll down the page. There we go. And divisor. Underscore that. And the number of parts required. And the number of parts required is the quotient. So let's go check quotient. And that's quotient, like so. All right. Underscore. Semicolon. And when I find the quotient and when I find the quotient, comma, I am said to divide 156 by 13. That's the end of the first paragraph, and that's also the end of Article 69. So now we'll go ahead and read back through that. Article 69. Suppose I ask whether 156 can be divided into a number of parts, each of which is 13, or how many 13s 156 contains. I propose a question. The solution of which is called division. In this case, 156 is called the dividend, 13 the divisor, and the number of parts required is the quotient. And when I find the quotient, I am said to divide 156 by 13. Okay, next paragraph. This is paragraph number 70. the simplest method of doing this I think that's simplest, right? Ah, it's just simple and then ST. The simplest method of doing this is to subtract 13 from 156, is to subtract 13 from 156, and then to subtract 13 from the remainder, and then to subtract 13 from the, what is remainder? Is it remainder? Let's take a look. Yes, okay, so it's remain and remember are the same terms. So then remainder is simply throwing the R on the end. Oh. Okay. Subtract 13 from the remainder, comma, and so on. And so on, semicolon. Or in common language, or in common language, used to be common language, to tell off 156, to tell off by 156, by 13s. A similar process has already occurred in exercises on subtraction. And what is already? Why am I blanking on it? Already. Let's check it. Yeah, I was just blanking on it for a second. Has already occurred. Oh, what does occur? OKR? OKR? And then an underscore, is that occurred? Yep, and then occurred is just to put it underneath. A little bit of a sharper. There we go. Has already occurred in the exercises on subtraction. Occurred in the exercises. Let's go check that out. Okay, so exercise, and then you just have the S on there. And that S then gives me the S. Gives me plural. On subtraction. What's funny now is now the pen feels a little sluggish, so I'm going to go over to preferences, and hopefully it's not just a problem with the Wacom tablet. So if I go down here and I go to the Gaussian, drop it down to 2.45, hit OK. Maybe that'll help. Let's try that. Subtraction. In the exercises on subtraction, comma, and that one was Article 46, according to 46. Okay. Period. Do this and mark 1 for every subtraction. Do this and mark 1 for every subtraction that is made comma, to remind you, now remind is pretty sure it requires an IE, right? Yep. To remind you that each subtraction takes 13 once from 156. Comma. Which operation will stand as follows? Which operations will stand as follows? Which, and then operation. OPR shun, right? OPR shun. Oh, that's right. You have to have the Asian. Which operations will stand as follows? Semicolon, or no, colon. And for that, I need to lay those out. No, I'm not going to lay it out because then I think it just gives the explanations. So we go ahead and begin. Begin by subtracting 13 from 156. Which gives 143. Period. Subtract 13 from 143. Comma, which leaves 130. Let me check leaves. Yep, good. 130. Semicolon. And so on. I wonder, and so on is a very common phrase, or at least it used to be. Let me check and see if it... Yeah, it's right there. Huh, well, that's one I made. Yeah, I mean, that kind of works. Maybe not quite that curved. Let's see what happens if I do and so on. Yeah, that looks okay. And so on. And so on. There we go. Period. At last, only 13 remains. At last, 13 only remains. Remains. There we go. A comma, from which, when 13 is subtracted, from which, when 13 is subtracted, comma, there remains nothing. Period. Upon counting the number of items which you have subtracted 13, is that counting? No, that's country. Oh. On counting. Come on. The number of times which you have subtracted 13, comma, you find that this number is 12. that this number is 12, semicolon, or 156 contains 12 13s. Or 156 contains 12 13s, or contains 13 12 times, or contains 13 12 times. Period. End of paragraph. Let's go ahead and finish out this other paragraph, and then we'll go ahead and read all of 70. This method is the most simple possible. Okay, comma, and might be done with pebbles. Back to his idea of the pebbles again. And might be done might be, that's maybe. What about might be? Oh, that's right. Yes, we do the diphthong, might be, to separate it from maybe. And might be done with pebbles. Comma, or no period. Of these, you would first count 156. Period. You would then take 13 from the heap. And then put into one heap, and put them into one heap by themselves. Semicolon. No, that's a period. You would then take 13 from the heap and put them into one heap by themselves, period. You would then take another 13 you would then take another 13 from the heap and place them in another heap by themselves. That's another. Is that also another? Other and another? Yes. Place them in another heap. By themselves. Semicolon. And so on until there were none left. None. Let me check none. Other way, okay. So there were none left. Let's go fix that. Move this up the page a little bit. Period. You would then count the number of heaps. Comma, which you would find to be 12. Period. All right, so now I can go back and read through all of number 70, article 70. See where that paragraph marker was, if I remembered to do it. The simplest, there's 69, and where was 70 by 13? Here it is. Let's go ahead and mark it. We begin. The simplest method, let me check method. Yes, good. The simplest method of doing this is to subtract 13 from 156 and then to subtract 13 from the remainder and so on. Or in common language, let me check common. Yep, in common language, to tell off 156 by 13s. A similar process, and curve that down just a little bit more for process. There we go, that'll do. A similar process has already occurred in, occurred's a little too long, it should be OKR and then hyphen, has occurred in the exercises on subtraction in Article 46. Do this and, let's go ahead and fix the and. Do this and mark. See if mark is correct. Yep. And mark 1. Do this and mark 1 for every subtraction that is made to remind you that each subtraction takes 13 once from 156, which operations, yep, which operations will stand as follows. Next paragraph. Begin by subtracting 13 from 156, which gives 143. Subtract 13 from 143, which gives 130, and so on to last, is that what it is? And so on, at last. There you go. Let's make that S just a little bit nicer. At last, 13 only. There we go. At last, 13 only remains, from which, when 13 is subtracted, there remains nothing upon counting. There we go. Upon counting, upon counting the number of times which you have subtracted 13, you find that this number is 12, or 156 contains 12 13s, or contains 13 12 times. This method is the most simple possible and might be done with pebbles. Of these, you would first count 156. You would then take 13 from the heap and put them into one heap by themselves. You would then, let's make then just, it's the bane of my existence. Then should be short. You would then, there we go. Okay. You would then take another 13 from the heap and place them in another heap by themselves, and so on. Oh, and there we go. So let's do and so on as a phrase, and so on until check until until there were none left. Till there were none left. You would then, yep. There we go. You would then count the number of heaps which you would find to be 12, And that's the end of 70. So now we start in on 71. Thus we begin. (71) Paragraph marker. Division is the opposite of multiplication. Division is the opposite of multiplication. Period. In multiplication, you have a number of heaps. You have a number of heaps, comma, with the same number of pebbles in each. Comma, and you want to know how many pebbles there are in all. Period. In division, you know how many there are. You know how many there are in all. And how many there are to be in each heap. And how many there are to be in each heap. How many there are to be in each heap. Comma, you want to know, and you want to know how many heaps there are. And you want to know how many heaps there are. Period. And that is, so that was all of 70, 71. So let's go ahead and read back through that. '71. Division is the opposite of multiplication. There we go. Division is the opposite of multiplication. In multiplication, you have a number of heaps with the same number of pebbles in each. And you want to know how many pebbles there are in all. In division, you know how many there are in all, and how many there are to be in each heap. And you want to know how many heaps. And we underline heap. How many heaps there are. That was all of 71. Continue. Get a little bit of water first. Okay. Continuing. 72, paragraph 72. Highlight it, and we begin. In the last example, a number was taken, which contains an exact number of 13s. But this does not happen. But this does not happen with every number. Let me check happen. Period. Take, for example, 159. Follow the process of Article 70. Comma. And it will appear that after having subtracted 13 12 times, and it will appear that after subtracting 13 12 times, there remains, is that remains? Nope, R-E, long M-N stroke. There remains 3 from which 13 cannot be subtracted. There remains 3 from which 13 cannot be subtracted. Period. We may say that the 159 contains 12 13s, and 3 over. Semicolon, or that 159 when divided by 13 gives a quotient of 12 when divided by 13, comma, gives a quotient of 12 and a remainder of 3. If we use signs, comma, then we get the following result. 159 is equal to 13 multiplied by 12 plus 3. 159 is equal to 13 times 12 plus 3. Okay? And I'm going to skip past all the exercises in the end of 72. We go straight over to 73, but before that, let's go ahead and read over 72. Get a little sip of water first. Okay, 72. In the last example, a number was taken which contains an exact number of 13s, but this does not happen with every number. Take, for example, let's fix that a little bit. There we go. Take, for example, 159. Follow the process according to Article 70, and it will appear that after, let's make the F just a little longer. There we go. That after subtracting 13 12 times, and is that and? There remains 3, from which 13 cannot be subtracted. We may say that the 159 contains that 159, not that the, it sounds rather poetic. We may say that 159 contains 12 13 times. 3 over contains 12 13s and 3 over. Or that 159, when divided by 13, gives a quotient of, in fact, and that should be underlined, right? A quotient of 12 and then remainder is also underlined. A remainder of 3. If we use signs, then the following is true. 159 is equal to 13 times 12 plus 3. Alrighty. Very nice. Very nice. Ouch. Let's continue, shall we? Yes, we shall. Back up to the next paragraph, and we're skipping past the examples and going straight to 73. Okay? And we're putting this in algebraic form. Paragraph marker. '73. If A contains B q times, if A contains B q times with a remainder R, comma, A must be greater than BQ by R. That is comma, and then we have our form here. A is equal to B, B, and then Q, R. BQ plus R. Okay? If A contains BQ times with a remainder R, A must be greater than BQ by R. That is, A is equal to BQ plus R. If there be no remainder, and the next line down, if there be no remainder, comma, A is equal to BQ. Period. Here, A is the dividend. I think that was dividend, right? D and then in D. Okay. A little bit more curve in it. A is the dividend, comma, B the divisor. B the divisor. Fix this up a little bit more. Comma. Q the quotient. And R the remainder. In order to say that A contains BQ times, comma, we write A over B is equal to Q, or the quotient, right? So A divided by B is equal to the quotient, or another way to say it, or another way to write it, or A ratio, the ratio symbol, B is equal to Q, comma. Shift this whole unit over. There we go. Okay, which in old books is often written thus. Oh, interesting, interesting. De Morgan calls that an old book. Wow. I didn't know that that was the older symbol. For some reason, I thought that was the newer one. Interesting. Okay. Which in old books, so these are the three forms. Which in old books is often written thus as a division symbol B is equal to Q. Okay? So that's all of 73. Okay. And let's go ahead and read back through before we go on to 74. Here's 73. If A contains B Q times with a remainder R, A must, here we go, A must be greater than BQ by R. That is, A is equal to B times Q plus R. If there be no remainder, A is equal to BQ. Here, A is the dividend, B the divisor, Q the quotient, and R the remainder. In order, is that in order? In order, so that should be upside down. That would be would, or I would. In order to say that A contains B Q times, we write A over B is equal to Q, or B ratio, or A ratio B is equal to Q, which in old books is often written thus: A division symbol, B is equal to Q. All right, so that is 73. Let's go ahead and start in. I only have about 3 minutes left, but we'll go ahead and start in on paragraph number 74. Okay? Paragraph 74. If I divide 156 into several parts, if I divide 156 into several parts, comma, and find how many and find how often, $13 is contained in each of them. Comma. It is plain that 156 contains 13. As often as all its parts together. Is as often as another phrase? As often as. As often as, because often is... Okay. So maybe as often as would make sense to do that as another phrase as well. And we've done as much as often as. Yeah, that would work. Oh, we're getting close to the end of our time, so let's go ahead and write down as often as. Okay, good. So we've got that written down. And for that one, that looks like this. We'll go ahead and erase that. And we go as often as. Now, the tricky thing is it looks like soften as, right? So, oh, there's our time. Sorry, that was a little loud. But soften as, softens. 13 softens. So we could, if we wanted, we could flip it around to do as often as, to kind of set it apart. But anyway, that was our time for right now. So we'll go ahead and take a break, and I'll be back shortly to do the next set. So hope everyone's having a good day. See you in a little while. Bye-bye.